Introduction to digital circuits. Digital circuits are those circuits which generate discrete signals, and all levels within a band represent the same signal state. Logic levels are the number of states a signal can have. It could be either a 0 or 1. If P is a signal, it represents 1. Then P represents 0. Logic gates. Introduction. Logic gates are devices which generate a logical output when one or more logical inputs are provided. AND gate. The functioning of the AND gate is shown in the truth table. AND gate is represented as shown. Implementation of AND gate. Two transistors are required to implement AND gate. OR gate. The functioning of the OR gate is shown in the truth table. OR gate is represented as shown. Implementation of OR gate. Two transistors are required to implement OR gate. NOT gate. The functioning of the NOT gate is shown in the truth table. NOT gate is represented as shown. Implementation of NOT gate. One transistor acting as switch is required to implement NOT gate. NAND gate. The functioning of the NAND gate is shown in the truth table. NAND gate is represented as shown. Implementation of NAND gate. Two transistors are required to implement NAND gate. NOR gate. The functioning of the NOR gate is shown in the truth table. NOR gate is represented as shown. Implementation of NOR gate. Two transistors are required to implement NOR gate. XOR gate. The functioning of the XOR gate is shown in the truth table. XOR gate is represented as shown. Implementation of XOR gate. 6 transistors are required to implement XOR gate. XNOR gate. The functioning of the XNOR gate is shown in the truth table. XNOR gate is represented as shown. Implementation of XNOR gate. 6 transistors are required to implement XNOR gate. Universal logic gate. NOR and NAND gates alone can reproduce the outputs of all other logic gates. Hence they are called universal gates. Representation of NOR gate as AND gate. As shown in the figure, AND gate is constructed using NOR gates. Perform tests with all sets of inputs and check the output. Representation of NOR gate as OR gate. As shown in the figure, OR gate is constructed using NOR gates. Perform tests with all sets of inputs and check the output. Representation of NOR gate as NOT gate. As shown in the figure, NOT gate is constructed using NOR gates. Perform tests with all sets of inputs and check the output. Representation of NOR gate as NAND gate. As shown in the figure, NAND gate is constructed using NOR gates. Perform tests with all sets of inputs and check the output. Representation of NAND gate as AND gate. As shown in the figure, AND gate is constructed using NAND gates. Perform tests with all sets of inputs and check the output. Representation of NAND gate as OR gate. As shown in the figure, OR gate is constructed using NAND gates. Perform tests with all sets of inputs and check the output. Representation of NAND gate as NOT gate. As shown in the figure, NOT gate is constructed using NAND gates. Perform tests with all sets of inputs and check the output. Representation of NAND gate as NOR gate. As shown in the figure, NOR gate is constructed using NAND gates. Perform tests with all sets of inputs and check the output. Buffers. Unidirectional buffer. Unidirectional buffer allows signal to travel from input connected to output of circuit 1 to output connected to input of circuit. Bidirectional buffer. A bidirectional buffer allows the signal to travel in both directions. That is, both can be inputs as well as outputs. Tri-state buffer. In addition to the logic 1 and 0, Tri-state buffer enables output of high impedance. Applications of tri-state buffer. Tri-state buffers are used to prevent short circuits. Latches. A latch is a device with two stable states. As it has a feedback path, information can be stored in a latch. SR latches. A set-reset latch is independent of any control signals and functions when set and reset inputs are given. SR NOR latch. A SR latch made up of two NOR gates as shown in the figure. SR NAND latch. SR latch made up of two NAND gates as shown in the diagram. JK latch. A JK latch's functioning is similar to SR latch, the only difference being that when both the inputs are 1, output is made to toggle. Gated latches. A gated latch is a latch with an enable signal attached to it. Gated SR latch. The gated SR latch is an example of gated latches where latching begins only once the enable line is high. Gated D latch. A gated D latch consists of a clock based on which the output is given. If clock is high, input is given to output, else output is held. Flip-flops. A flip-flop is also a bistable multi-vibrator like latches and can store information too. The only difference is that flip-flops are clocked devices. D flip-flop. In a D flip-flop, the input signal is sampled with the clock signal, and then based on the rising edge signal of the clock, the output is given or else held. T flip-flop. Toggle flip-flop, also known as T flip-flop, toggles the output of the previous state if the input is high or else uses the same output. JK flip-flop. A JK flip-flop is similar to SR flip-flop, where J equals set, K equals reset, and when both inputs are 0, the previous state remains, and when both are output toggles. Registers. Registers are small amounts of storage spaces in a processor where all the data is stored. Data registers holds numeric values, characters, floating points. Address registers holds addresses and are used to access memory. General purpose registers used to store both data and addresses. Special purpose registers holds the program state, program counter and status register. Internal registers used only for processor operations. Counters. A counter is a device which stores and displays the number of times a particular event or process has taken place. Asynchronous counter. Changing state bits are used as clocks. Synchronous counter. All bits change under a single clock. Decade counter. Counts through 10 states per stage. Up-down counter. Counts both up and down under command of a control input. Multiplexers. A multiplexer or MUX is a device with several inputs, analog or digital, and a single output. Applications of multiplexers in communication system, in telephone line networks, inside computer memory. Demultiplexers. A demultiplexer or a DMUX has one input and more than one outputs. It is used to send output to various devices. Applications of demultiplexer in communication systems, in ALU inside computer, in serial to parallel converter. Logic family. A logic family is a set of digital integrated circuits with compatible logic levels and power supply characteristics within the family. Bipolar logic family. The bipolar logic family consists of transistors and diodes. Transistor logic is a member of bipolar logic family. TTL, transistor logic consists of bipolar junction transistors and resistors. The logic gating function and amplifying function are performed by transistors. Power dissipation is 10 milliwatt per gate. Propagation levels are 10 nanoseconds. Voltage levels range from 0 to 5.25 volts. Unipolar logic family. Unipolar logic family consists of MOSFET devices. PMOS. PMOS uses P MOSFETs to implement logic gates. They create inversion layer in the N-type transistor body. NMOS. N-metal oxide semiconductor uses N-type MOSFET for logic gating in digital circuits. CMOS. CMOS uses complementary and symmetry parts of P-type and N-type MOSFETs for logic functions. High noise immunity, low power consumption are the main characteristics of CMOS. Digital ICs. Digital ICs are used in computers, computer networks. They are made up of logic gates and have a few defined states. Characteristics of digital ICs. Fan-out. It is the number of input gates to which the output gate can accept. Power dissipation. It is equivalent to the heat dissipated by the IC. Fan-in. It is the maximum number of inputs that a logic gate can accept. Noise margin. It is the amount by which the signal can exceed the minimum amount of operation. Latest trends in packaging. IC packaging was earlier done to protect the chip from environmental factors. Recently, ease of use by the customer is also considered while packaging. Hence, smaller packaging is done. Also, ICs are packed in thin formats to achieve more performance per mm. Conclusion. In this chapter, the users have covered the following aspects of digital and integrated circuits. Introduction to logic levels and gates, latches, unidirectional and bidirectional buffers, tri-state devices, clock generators, flip-flops, registers, counters, multiplexers and demultiplexers, introduction to various logic families and their characteristics, bipolar logic family, unipolar logic family, PMOS, NMOS, CMOS, characteristics of digital ICs, comparison of digital logic families, latest trends in packaging.